गया कॉपी, इरेज कर दे। तो पहले हम लोग डिस्कस करेंगे फ्लूइड क्या होता है, ठीक है। तो व्हाट इज फ्लूइड, क्या जानते हो फ्लूइड के बारे में? इट कैन फ्लो, तो व्हाट डज इट मीन? फ्लो करने का क्या मतलब होता है? फ्लो मीन्स देखो फ्लूइड मीन्स जैसे 3 स्टेट तुम लोग जानते हो ना, मैटर का 3 स्टेट होता है, सॉलिड, लिक्विड एंड गैसेस। तो लिक्विड एंड गैसेस कंबाइंड आर कॉल्ड फ्लूइड्स, ठीक है। तो जिनका शेप फिक्स नहीं होता है, जो फ्लो कर जाते हैं। ये सॉलिड में क्या होता है, शेप भी फिक्स होता है और उसका जो वॉल्यूम होता है वो भी फिक्स होता है। इन सॉलिड्स यू हैव द शेप ऑफ द object fixed and its volume is also fixed. But if you consider the liquid, its shape is not fixed, but volume remains nearly fixed. But for gases, neither volume nor the shape, nothing is fixed. So fluid means which can flow, and which can flow means we can understand that its shape does not remain fixed. It takes the shape of the container. Write the definition of fluid. It is state of matter which can flow. Gases and liquid combined are called fluids. But primarily we will study the motion of liquid in this chapter, and many of the things which we study for liquid are also applicable for gases, but not all the things which we are going to study will be applicable for gases, but most of the things are also applicable, and in this chapter we will study mainly for liquids. So the first thing we will see the pressure in a fluid. What is meaning of pressure in a fluid? So write the topic, pressure in a fluid. तो देखो फ्लूइड में क्या होता है कि if you consider any point inside a fluid, pressure is felt from all the sides. If you consider the pressure in a fluid, if you take any point, the force is exerted from all sides at any point. So since the force is acting from all sides in equal amount, this point will not move, this point will remain stationary, okay. And if you consider any surface, the force acts perpendicular to the surface, ठीक है। तो ये प्रेशर का नेचर होता है, इसका जो फ्लूइड के अंदर जो प्रेशर लगता है ना, तो इसको लिख लोगे। If you consider any point in a fluid, forces act from all the sides on that point. If we consider any surface, then force is perpendicular to the surface. Force is perpendicular to the surface. And what is the unit of pressure?
Pascal.
Pascal. SI unit of pressure is Pascal. Newton per meter square, that is also called Pascal. So लिख लो unit of pressure. So the SI unit is 1 Newton per meter square, that is 1 Pascal. Okay. Okay, this is the main unit. But apart from this, we have other various units. The other most important unit is atmospheric pressure. That is also written as 1 atm. 1 atm, and that is also written as 1 bar. Okay, 1 bar. And this is equal to the pressure of atmosphere at sea level. This value of pressure is equal to the atmospheric pressure at sea level. And if you convert it into SI unit, that is approximately 1 point below 013 into 10 to the power 5 Pascal. Okay, so you can, but this is very small, so we write directly 10 to the power 5 Pascal. Okay. One more unit we have, that is called torque. So how much is this value? Point? 0.97. देखो मैं बता रहा हूँ. 1 mm of Hg. This is the main definition, and then you can convert it into Pascal. 1 millimeter of Hg. This is also one of the unit. Millimeter of Hg or centimeter of Hg means the column of a liquid is going to exert some pressure. The pressure exerted by that column is, if it is the pressure exerted by 1 mm of column will be considered as 1 mm pressure. ठीक है, तो इसको हम और डिटेल में अभी देखेंगे. एक्चुअली तुम लोग जानते हो प्रेशर कितना होता है लिक्विड के अंदर, रो जीएच होता है. ठीक है, तो इसका वैल्यू कितना हो जाएगा, रो जीएच 1 mm of Hg. रो GH, if we write रो for mercury, we have to write. So रो for mercury is 330 in SI unit, this much kg per meter cube, and G is 10, and height is 1 millimeter, means 10 to the power minus 3 meter. So if you solve it, 136 you will get. 136. 136 Pascal is equal to what torque? 136 Pascal is equal to 1 torque. Okay, you will find like this. And if you convert the atmospheric pressure into this millimeter or centimeter of Hg, then centimeter of mercury, then you will write 1 atm equal to 76 centimeter of mercury. Okay? And you can multiply it and you can see centimeter of mercury. So this is millimeter of mercury. Centimeter of mercury will be how much? 10 times of this. So 1360 Pascal. 1 centimeter of mercury is this much. 1 millimeter of mercury is this much. So 1 centimeter of mercury is 10 times of that value. If you multiply it, how much you should get? In Pascal, 1 atmospheric pressure is this much. So you should get approximately 10 to the power 5 Pascal. These are the different units which are used in while dealing with pressure. Okay. And how do we get the pressure to be equal to rho GH? that we are going to see now. The pressure variation in a fluid. तो देखो एकदम सिंपल है, मान लो एक फ्लूइड कहीं पर दिया हुआ है, ठीक है, वी कंसीडर ए cylindrical part, we consider a cylindrical part inside the fluid, and we will write the forces on this part. So if you write the forces, what are the different forces? We have just seen the forces act perpendicular to surface. So one force will act from above, other force will act from below, and rest will act from sides like this. So the different forces which will act on this cylindrical object, cylindrical assumed volume will be like this. So we can write P1, P2, and we will measure the height from below. नीचे से measure करते हैं हम, ठीक है? We will measure the height from below. Suppose this is Z direction. Okay. So and this is delta Z. ठीक है? And this is area. So if we write the different forces, what will be the forces? First is, we'll draw the atmospheric pressure सब हटा दिए हैं कि तो बस इस पर लिख रहे लिक्विड के अंदर देखो, draw the free body diagram. P1A from above, P2A from below, and weight of this part mg, density ले लो इसका रो ले लो, density of liquid, density of liquid, and one force from this side, other force from this side. Since this part is static, the liquid is static, stationary, all these forces will be balanced. Sideways forces will be balanced because this part is at some depth and the diametrically opposite point at same depth. So they will balance each other. And we will only have vertical forces. So if you want to write, we can write like this: P2A equal to P1A plus mg. ठीक है? And you can write P2 minus P1 minus P2, P1 minus P2A equal to minus mg, which is same as minus m will be how much? Density times area times delta Z G. Can we write density into volume is mass? Okay. This can be written as delta P into A equal to minus rho A delta Z G. A cancelled. Delta P equal to minus rho G delta Z. Okay. Okay. In this expression, we have assumed the density to be constant, G to be constant. Then we have written this expression. But if these things are variable, if rho and G are variable, then what we can do is, instead of taking this much length of the column or cylinder, we can assume very thin part, and then this can be written as dP rho G dz for infinitesimally small size of delta Z. Then in the form of calculus we can write it. So for a change of delta Z height in the liquid, as you move up, the pressure will decrease and it will be given by this value. Are you getting? And if you want to find the change of pressure, then we have to integrate it. This is the actual formula for finding the pressure difference. As we move up, the pressure decreases. The minus sign is indicative here. But if you measure the depth from the surface of water, since we are measuring in the opposite direction, the measurement is not on the plus y direction, it is on the lower side, then pressure increases. Okay? And normally for water, rho and g are constant. So we can directly write delta P equal to rho g d, where d is depth. For water or liquid. For liquid we can write like this. As we go below, the pressure will change with depth. It will increase with depth. But this formula is especially useful for gases, because in gases you will have large variation of densities. If you suppose we want to measure the pressure of atmosphere. In atmosphere, if you want to find this thing, how do you find? We have to go up to thousands of kilometers for finding this pressure. At very large heights, some thousands of kilometers, the pressure is 0. And as we come down, the pressure increases. Rho as well as G, both will change. ठीक है? तो ये सब होता है. तो अभी हम देख लेते हैं इसके बाद एटमॉस्फेरिक प्रेशर क्या होता है. ठीक है? राइट? एटमॉस्फेरिक प्रेशर का वैल्यू कितना होता है और कैसे आता है. वैल्यू तो कितना होता है देखिए नहीं यहाँ पर. Atmospheric pressure. So atmospheric pressure is due to the gases found in atmosphere, and its value is, we write generally as P naught 10 to the power 5 pascals. It means per meter square how much Newton is there? 10 to the power 5 Newton per meter square. And 10 to the power 5 Newton is equivalent to what? How much weight? Is it equivalent to 10,000 kg? 10 to the power 5 Newton means 10,000 kg, equivalent to weight of 10,000 kg. It means that if you consider a 1 meter square area on the earth's surface, then the column of air which we have on this area up to the very large heights, that will have the weight of 10,000 kg. The gas has that weight. So that much weight is continuously acting on us. 10,000 kg of weight is acting per meter square of area. Okay, तो बहुत since it is in our daily life, we are not able to realize this pressure, but this pressure is very large, and you can see how large this pressure is. If you remove all the air from a container and close it, then pressure is what? If you remove all the gases, then pressure inside is 0, and you have only pressure outside. So that due to that outside pressure, that container will get compressed, and compression can be very, very strong. And how strong it is, that was shown by a scientist in Europe 300-400 years back. What he did, he took a sphere of very thick metal, and that sphere was cut into two parts, and the grease and all the things were put, and it was made airtight, and then by using some vacuum pump this was evacuated, and you were having there two holders, and there were 7 horses used to open it, and up to 6 horses this was not opened. So 7 horses were required to open this, and this thing, the sphere was of this much size only. So you can see how strong this atmospheric pressure is. ठीक है, बहुत ही ज़्यादा होता है, पर हम लोग को पता नहीं चलता है. ओके, ठीक है, समझ में एटमॉस्फेरिक प्रेशर. तो वैल्यू लिख ही चुको. ठीक है, एक लाइन लिख लो इसके बारे में. This pressure is due to the column of gases. This pressure is due to the column of gases present on the any area at Earth's surface. There is one more term called gauge pressure. ठीक है, gauge pressure और gauge pressure इसको ऐसे लिखते हैं. देखो ये क्या होता है. In most of the questions or in most of the discussions, what we have is, suppose we consider the pressure. The atmospheric pressure is always added. ठीक है, suppose we take 2 points from here to here. We will write the pressure. So here also, apart from atmospheric pressure, we will have some pressure added, and here also, apart from atmospheric pressure, some other pressure will be added. So at all the pressure, atmospheric pressure is always present. So for our discussion or for solving the problem, we do not need that atmospheric pressure. We only discuss the extra pressure over the atmospheric pressure. Suppose at some place, due to we have a water in some container, and we want to find the pressure at depth of suppose 10 centimeter. So we can find with the formula rho g d. D will be 10 centimeter. We can find the pressure, but that pressure rho g d is not the pressure at that point. The actual pressure at that point is P equal to P naught, the atmospheric pressure, plus rho Gt. This is the actual pressure at any point in the liquid. But every time we are not going to add 10 to the power 5 Pascal plus that extra pressure. So instead of doing that, we define a term gauge pressure. This gauge pressure is the extra pressure over the atmospheric pressure. Okay, this is extra over the atmospheric pressure. So what is gauge pressure? P minus P naught. This is the gauge pressure. This is the extra pressure. ठीक है, लिख लो इसको. So the extra pressure over the atmospheric pressure is called gauge pressure. ठीक है, ये हो गया. Okay. Next concept we will do Pascal's law.